This is the study of geography, and these are the branches of geography: physical geography, human geography, and practical geography. These are among the few topics that we look at when we study geography. We look at industrialization, we look at forestry, we look at tea plantations, maize plantations, brick making industry, among many others.
Hi, this is your geography teacher Nyakundi, and we are in Geography Form 2, Lesson 10. Our study is about the internal landforming processes, and we were looking at faulting. Last time we talked about, we defined faulting, and we looked at the types of faults that are formed and the forces that are responsible for the faults. And we also looked at the features or the landforms that result from faulting. And today I would like us to look at the last feature that we did not talk about, because in our last lesson I remember we talked about faulting can lead to the formation of an escarpment. It can lead to the formation of a block mountain. It can also lead to the formation of a tilt block or tilted landscape. When the tilt blocks occur in a series, then we don't call it a tilt block, we call it a tilted landscape. And we did not talk about the last feature, that is the Rift Valley. The Rift Valley is as a result of faulting. In most cases it is a product of faulting. Now a Rift Valley, like we have the Great Rift Valley of East Africa or of Africa, it is believed to have been formed due to the faulting process. Now we have the formation of the Rift Valley can be due to tensional forces, or it can be due to compressional forces or anticlinal arcing. Now we look at Rift Valley as a result of tensional forces. How does it happen? We have a diagram here, an illustration, that the layers of the rock, the crustal rocks, were before the faulting occurred, the land was like this. So these are the layers of the crustal rocks, and this is before faulting occurred. Then the land was now subjected to the tensional forces. Remember, tensional forces are pulling from the center towards the opposite directions, and they cause a lot of tension, which leads to the formation of fault lines. And these fault lines are the normal fault line, and that is what we have in our second diagram. Now that the tensional forces here, these are the tensional forces which are pulling away from each other, and they have led to the formation of the normal fault line. So the crustal rocks have been, they were calm here. Now they have been subjected to tensional forces, and they have led to the formation of normal faults. Then we move down and we see what will happen. We have, after the formation of the normal faults, now continued pulling away, continued tensional forces will lead to the middle block, because when we have the tensional forces, maybe we go back, and we see that when we have the tensional forces here, we can say this is one side of the crustal rocks, and this is the middle block, and this is another block. So we have two blocks, one on either side, and the middle block. Now when we continue having, or the crustal rocks continue to experience the tensional forces, the middle block may sink, and leaving the blocks on either side in their original position. You see? Now then, the land that has sunk in between is what forms the Rift Valley. So we have flat land at the midro and escarpments on either side. So that is formation of a Rift Valley through tensional forces. The layers of the crust were subjected to tensional forces that led to the formation of a normal faults. Then continued tensional forces would lead the midro block to sink, while the blocks on either side are left in their original position. The Rift Valley can also be formed through compressional forces. These are forces which are acting on the crustal rocks from either side. They are pushing the crustal rocks towards each other. So these forces, they act like that. We have the compressional forces acting on the layers of the crustal rock. Remember, these rocks are hard rocks, so they are going to crack. They are not going to bend. They bend during when they are young. These ones are hard basement rocks, and they have been subjected to compressional forces. Now, the compressional forces will lead to the formation of the reversed faults, and then so we have the blocks on either side of the reversed faults, and we have the midro block. Now, continued pushing of the compressional forces will lead to the land on either side to be pushed up, while the midro block remains in its original position, and therefore we have a Rift Valley. Now, we may have the hanging blocks here. With the compressional forces, we are going to have the hanging pieces of the crustal rocks. They will be acted upon by the denudation processes. There is weathering, there is mass wasting, there is erosion. All those ones, they will work on it, and they will shape the sides of the Rift Valley. So that is how the Rift Valley is formed through compressional forces. So we have seen through tensional forces, and then we have through compressional forces. We also have a Rift Valley being formed through anticlinal arcing. That is when the forces, compressional forces, are too strong, they may cause the anticline to crack and have very serious and gaping faults, very large cutting on the anticline, and that one may form. Now, when the cracks are several, they may collapse, and they may cause the Rift Valley to be formed there. So that is what we have. Then we look at the Great Rift Valley. In the world, we have so many Rift Valleys, but in our case in Africa, we have the one that is most famous, the Great Rift Valley. That is the Rift Valley where we are here in Kenya. And the Great Rift Valley does not start from Kenya. It starts from somewhere in Syria, then comes down through the Dead Sea, then comes through the Red Sea, enters into Ethiopia, enters into Kenya, runs down into Tanzania, goes down to Malawi, and then enters into Mozambique. You see, starts from Syria, runs down into the Dead Sea, then we have the Red Sea, then we have Ethiopia, Kenya, Tanzania, Malawi, and Mozambique. Then when it is just about to enter into Malawi, in the southern part of Tanzania, where we have Lake Rukwa, it divides into two to give rise to the formation of two branches. We have the eastern branch and the western branch. The eastern branch is the one that is running through Kenya, and the western branch runs now down from, it runs from the Lake Tanganyika, runs up, coming up and enters into Lake Edward of Western Uganda, sorry. So that is how we have the Rift Valley like that. And then we have the Rift Valley lakes. Those were the cracks which occurred, and they were filled with water. So we have several of them. We have Lake Turkana, Lake Naivasha, Lake Nakuru, Lake Rukwa, Lake Malawi, Lake Tanganyika, of course the deepest of them all, and that is it. Then we move on to see the effects of faulting, on drainage. The faulting may have some effects on drainage, that is on the movement of water or the occurrence of water on the earth surface. Number one, when cracking occurs on the earth surface, it might be deep enough to contain water. So when it contains water, if a crack contains water, then that forms a lake. So faulting may lead to the formation of lakes. That is when there's cracking on the earth surface, we may have water collecting in them, and we have named several examples of these lakes. You can name Lake Nakuru, Lake Turkana, Lake Baringo. Those are lakes that are found in the Rift Valley, and that is how they were formed. Number two, sometimes when we have faulting taking place, it may lead to the formation of an escarpment. And if there is a river that is flowing through that place, that point where there is an escarpment, the river may form a waterfall. So faulting can be responsible for the formation of a waterfall. Waterfalls, one of the points that makes them to occur is faulting. Then sometimes when a river is flowing and we may have such a serious crack, very deep crack like that, it may lead to the disappearance of a river. Yes, if there is a river that is flowing through that point and then we have a crack, the water may flow into the crack and the river disappears. Now, we may also have faulting occurring, and then it leads to the reappearance of a river. As much as we have a river disappearing, maybe it disappeared upstream. Then downstream we may have another deep crack, and we may have a river appearing. So it may lead to the disappearance of a river, it may lead to the appearance of a river, reappearance of a river. We have also said that it can lead to the formation of a waterfall, where we have an escarpment happening when there's across a river. Then we have the formation of lakes, as we have said. We may also have rivers may change their direction. Like if a rift valley is forming through compression of forces, we may have the sides rising up, and so because of the rising of the sides, the river might change its course and it might flow backwards. What we talk about when we are talking about back-tilted drainage systems. So we have a river being forced to flow backwards and changing its direction. We may also have a river change the pattern. The drainage, the drainage pattern, of course, but it might be fault guided. They may flow through the cracks. So those are the various ways through which faulting may lead to, may affect drainage. It can form drainage, faulted guided drainage. It may lead to the reappearance of a river, disappearance of a river, formation of a lake, or formation of a waterfall. Then now we talk about the significance of faulting. Is faulting important? Yes, it's very important. Faulting, when it takes place, when cracking takes place like that, it may lead to the formation of very beautiful features like the Rift Valley, and we are going to have the Rift Valleys, escarpments, tilled blocks. They attract tourists, and we are going to have foreign currency. It may earn us some foreign money, foreign exchange. Then we also have the faulting may lead to the formation of lakes. Of course, we have talked about the cracks may contain water, and if we have lakes, we may have fishing in the lakes. So faulting may lead to the formation of lakes, which may lead to the starting of fishing. We may also have the faulting that has led to the formation of lakes, which may provide water for home use. We also have faulting leading to the formation of the same lakes, which can be used, supply water for irrigation, supply water for industries and institutions. Faulting may also lead to the formation of an escarpment, And when an escarpment is happening, that means that there was some displacement of rocks. Some rocks were either moved upwards or they were moved downwards, and it may expose what? Minerals. And when we have minerals, then we are going to have that is a source of income. So it may expose minerals, and that was it might influence mining. Faulting may also break rocks when rocks are being displaced. And when we have rocks, of course, we are going to have use them for building and construction. So faulting is wonderful and it's good. Now, faulting is also one of the initial stages of soil formation. When the rocks are breaking, when the rocks are being displaced, there's a lot of breaking of the rocks. They may lead to the formation of, which may lead to the formation of soils later on. So soil formation can be a product of what? Faulting. Faulting, when it leads to the cracking of the ground or the crustal rocks, it may trigger volcanicity. So, which may lead to the formation of volcanic features, and that is also very important. Then we also have negative effects. Faulting might be very devastating. It might lead to the, it might trigger earthquakes, and earthquakes can be scary, you know. They might be very dangerous. Sometimes faulting may lead to the formation of an escarpment, which may make the construction of transport lines to become a nightmare. Even the maintenance of the same roads may become a nightmare. So faulting might be negative. It might lead to very difficult job in building lines of transport and communication. Faulting may lead to the formation of an escarpment, which triggers mass movement, and they might be very dangerous to people. So were it not for the formation of the escarpment, we would not have such things like mass movement. And so that one can also be a factor. We may also have the formation of tilt blocks and block mountains, which may not have rainfall on the leeward side. So they might be a problem. That one is the formation of leeward side of a mountain. It's because of tilting. So we have come to the good end of our faulting. It has been a good lesson, and I believe you have loved it. Thank you.
Continue watching this YouTube channel where you will get more similar content to help you during your study in high school, and kindly share so that your friends can get the same kind of content and be helped in their study as well. Thank you. Have a nice time.